Assalamualaikum warahmatullahi wabarakatuh. My name is Danish Farhan bin Muhammad Danish Farhan bin Rostan. My matrix number is 01 DDT 22F1039. So today I'm going to present about the questions one of the mini project. So the question one is write a simple C++ program that inserts a list data into stack S as shown as the following figure. At the end of the program, show the pop operations to remove all the elements from the stack. So I'm going to show you all the code that I made. Okay, first I'm going to write all this type struct stack. Then this is how the coding to push P to the stack. So we're gonna see if whether this stack is full or not. So if else, if the stack is not full, so we're gonna push P inside this stack. So and then this is the code to push P inside the stack. Then a stop character data U. Then we're gonna push U into the stack. If stack is full, then stack gonna push inside. So and then the next one is push O to the stack. So you're going to see if the stack is full or not. If the stack is not full, so again it will push the O into the stack. Then this is the code to print element in the stack. So element in the stack, it will show what element has been pushed into the stack. Then this is the pop operation to see what the element that we pop. Then first we check if the stack is empty or not. So if the stack is empty, so we can pop. First of all, see out pop element, then the first element, and then if the stack is empty, then it can pop. So the first thing that we pop, and then the second one is right here. Negative one, see out stack empty. If else, if the stack is not empty, so you can pop the element inside. So I'm gonna show you. This is the output. So the element in the stack is OUP, and then the element pop is first of all is 0 O, and then the second pop element is U, and the last pop element is P. So the all the element pop is OUP. That's all from me. Thank you.
Assalamualaikum to Puan Anissa. My name is Muhammad Aziz bin Nurudin. My matrix number is 01DDT21F1108. So today I will present about the structure mini project question number 2. Alright, so this is the question. So the questions want us to write a simple C++ program that insert a list of data into queue as shown in the following figure. At the end of the program, show the dequeue operation to remove all the elements from the queue. So we need to enqueue PUO. The size of the queue is 3. The index is 0, 1, 2. So this is my coding. So first I creating queue. Queue is the name of the queue. Using the struct queue using front and rear. Okay, then enqueue data P. So I use char declare data 1 as P, and I check full. If full, then you cannot enqueue. But else, I enqueue the P value into the queue. So then I do the same with U and O. So to remove all the elements from the queue, the first thing, so I use for int I equals 0, I less than 3, I plus plus. This is to loop the enqueue, this to loop the dequeue for 3 times because we have 3 elements. If queue front equal queue rear, that means queue is empty. If not, I dequeue the I dequeue the elements from the queue. So this is the coding for the queue. Cout queue list, also queue front, then align queue front plus plus. So before we dequeue, we need to see out the value first. So we know what value we dequeue. So if I run this, we can see that the first dequeue is P, second is U, and third is O. That's means I have dequeue all the elements inside the queue. So that's all from me. Then I'll pass it to Shafiqi.
Assalamualaikum warahmatullahi wabarakatuh. And very good morning. My name is Muhammad Shafiqi bin Rodari, and my metric number is 01 DDT 22F1107. Thank you for explaining the second question. I will explain about the third question. The question is write a C++ program to show implementation of binary search tree using linked list. Your program must include all the operation in binary search tree, including creating BST, inserting item into BST, count item in BST, deleting item from BST, and traversal of BST. So I will show you the coding. This is the coding. First of all, we must do the struct for the tree. For the member is data, and left and right. So after we creating the struct for the tree, now we need to create the node. So the BST new node to make a new struct, and we have to make sure the left and right is in a null value. So now we're using a function to return the new node. Next, we by insertion we declare one array by using pointer bst insert. Now we're using the function root and empty value. So if the root is a null, he will return to it will return back to a node. So it have a value, and if the value is smaller, it will go to the left. If and if the value is bigger than the root will go the value will go to the right to the right node. So this is for the count how many number using we insert the number. So this is how to find the minimum value. For information, I'm just using in order. So when I want to make in order, I need to find the minimum value so it can arrange from the small to the biggest. So the a function of deletion. For deletion, I will delete one number from putting five value. This all of these are for the one deletion only. So this is according for in order. If the root is equal to null, it will return to the first one. And if not, it will go like left or right. So this is after the recording all the function. Now we go to the main body to trigger the coding and the function that we will make. So first of all, we have to say that root is null, and now we insert the root value. The first value I put in 25, second is 16, third is 30, fourth is 6, and fifth is 32. So I show this without arranging the value. So I will make a setup for in order using the in order function, and this is counting how much the number actually before deleting, and this is for deleting. I delete number is 30. So my delete. So after this, it will show the value of after delete. So I run. Now we can see the value in order is 6, 16, 25, 30, 32. Before deleting, it was 5, first number. And in order traversal after deleting 30, it will become 6, 16, 25, 32. That's all from us. Thank you.